Right, hello, and I think we're far enough into January that it's safe to say Happy New Year to all time zones. Welcome to the first webinar of 2018. The title is Microservices in Dyalog APL, and of course, as usual, we go to Wikipedia to find out what microservices are. The definition says microservices are a variant of service-oriented architecture that structures an application as a collection of loosely coupled services. So instead of having your large monolithic application running on a desktop, you turn it into a bunch of small processes running independently that offer functions up to each other to call. Now, that is very modern and hip. The good news is that all of the techniques that we're going to be looking at today in this webinar will work fine for your monolithic heritage application as well. They're not really specific to microservices. What we're going to try and do in the next 60 minutes or so is to show you a way to make your APL functions easily available to be called from, in quotes, anywhere. And by anywhere, I at least specifically mean any development tool running on the same machine. So if you're using C# or JavaScript or Python, whatever, on the same machine, you should be able to call these APL functions easily. And the same should be true if you're running on a machine nearby or in fact anywhere on the internet. We're going to end by if the internet stays up, and I'm not entirely joking, we had GitHub itself down for about 45 minutes, the last 45 minutes before the webinar started. We're going to try and deploy the application to the cloud and show you that you can still call the functions when it's running there. So to build up a bit of an agenda here, the first thing we're going to do is inspect the application, and that can be done on this slide. This is the application. It's 3 lines of code that, given a two-element vector containing a month number and a day number, compute the name of the sign of the zodiac which the sun was in on that day, which is rather odd because it means that's a constellation you definitely could not see on that day because it's around the other side of the Earth. But some people find it useful to compute this, and we're going to use that as the application, our microservice that we're going to try and call. So we're going to park that away in a little box over here. The main technology that we're going to be looking at is something we've just created called JSON Server. I'm going to start showing that on Microsoft Windows. What it is a Conga-based, which if you're not familiar with Conga means it's a TCP server application that makes it easy to call APL functions with the argument coming in as in JSON format and the results also being passed back in JSON. Once we've got that up and running, we're going to test it from APL, and then we're going to test it again using something called curl, C-U-R-L, which is a command line tool for transferring data using various protocols that's available to Linux users, and you can also install it on Windows. It's just sort of a very general purpose tool for making web requests, just to show that we can call APL functions from there. Once we've got our JSON server up and running, we're going to create something called a Docker container, and we're going to do that under Linux. And containers are very similar to virtual machines, but they are very, very much easier and faster to build, deploy, and manage. And hopefully that's the sort of almost the main message of this presentation. Hopefully you will agree with me about that in 45 minutes. Once we've created the Docker container, we're going to, of course, test it under Linux, and when we're happy that it's working, we're going to store it in something called Docker Hub, which is an online repository for these Docker images. So we're going to push it up there, and the reason we want to do that is we could then easily pull it down to another machine, so we can have this thing running on all sorts of different machines easily. And the last thing we're going to do then is to create a Linux virtual machine out on Amazon in their Elastic Compute Cloud. We're going to create an empty Linux virtual machine there containing only the Docker tool, and we're then going to pull the image back down from Docker Hub, start it, and then just as a final test we're going to see whether we can make a call to it from Python programming language, just to demonstrate how easy it is to call things once we've done that. So there's many moving parts that we're going to whiz through over the next, hopefully no more than 60 minutes. Don't be worried if you can't follow all of it. Some of it is going to go faster than anybody could be expected to follow. But the intention is that the slides that will be uploaded after the presentation and the GitHub repository that's also going to be available, that is already available if GitHub is up, contains absolutely all of the materials that you need to replicate this at home. So do try this at home. Here we go. So the first step is to have another look at the application. Let's call it from APL. Serve it up with the JSON server, starting under Microsoft Windows, call it from APL and curl. JSON Server, as I said, is a TCP server based on Dyalog's Conga tool, which is included with Dyalog APL. So what it does is it receives messages like the stuff in the little green box up at the top. That's a slightly simplified HTTP post. But the important thing is it starts with the word post. There's then a name identifying a resource that you want to post to, which is getSign. That's actually just the name of the function that you want to call in the JSON server. And then there's a payload, which is in JSON format. So this square bracket 10,31 is a 2-element integer vector. What the JSON server will do is it will pass it through quad JSON and convert it to the APL array 1031. Pass it to the getSign function, get a result back, pass that back through quad JSON, and create in double quotes, because that's how a string should be formatted in JSON, the result, and return that as an HTTP result. So there's one very significant limitation of this that you need to be aware of as an APL programmer, and that is, of course, that the data needs to be representable in JSON. And that's for very many arrays, that's not a problem. The only real limitation I think you're likely to come up against is that you can't represent two-dimensional or higher dimensional arrays. JSON only deals in lists. You can have nested arrays, vectors of vectors. You can have namespaces containing variables. Those are representable as JSON objects, but you can't have multi-dimensional arrays. Now, in practice, this isn't really a limitation, because if you're calling from some other programming language, they're not going to want to deal with matrices anyway. They're going to prefer vectors of vectors. But it's just something you need to be aware of, that the results, you need to avoid matrices on input and output. Okay, so let's switch over to a demo. Now, all of the code that we're going to be looking at, including the APL demos that I'm going to run now, are on GitHub. So at this address, which is here, github.com/dialog.jsonserver, if I click on that and GitHub is up, there is a repository. Now you can either, if you have Git installed and you're familiar with Git, use a git clone command, or there's a typo there, that should say git clone, not git pull. I'll correct that before we upload them. Or if you don't want to use GitHub, you can click on clone or download here and click on download zip. Get a zip file and just unzip the contents. That'll give you all of the files to play with on your computer. Same way as if you had cloned the repository. I've copied them into /dev/JSONServer on my machine, and the examples will assume that, but you could put them anywhere you want if you just make the corresponding changes to the demo scripts, etc. Okay, so let's switch to APL and see if we can fire up a JSON server. So how's the font size? Make it a bit bigger. Yeah. So I've started the server demo script. Clear workspace, nothing up our sleeves. Large page width so we don't get any wrapping. I'm going to create a namespace called Zodiac, and I'm going to use the salt load command to load actually two functions. We only looked at one of them. show you what the other one does in a minute. So if we look at Zodiac get sign, it's what we saw on the slide a moment ago, and if we call it, then we can see that Halloween is in Scorpio, sign of the Zodiac. The other function called getSignObject assumes that you create an object, creating an empty namespace here and assigning two variables, month and day, into it. If I then call getSignObject, I get an object back which has three names in it, the month and day echoed back, and the sign as a character vector or a JSON string. In fact, if we pass that through quad.json, that namespace that was returned, we can actually see that even if you're just using APL, if you have a little namespace with a few variables in it, quad.json is actually a nice way of inspecting its contents. You get all the names and the values displayed, as long as there are no matrices in there. Right, so we have our application loaded in a namespace. We want to serve it up. We're going to load the JSON server into the workspace from the folder that we cloned the repository to. Create a new instance of the server. Tell it where our application is in the namespace hash.zodiac. Define the port number that we want it to listen on, and start the server. And it started. Now run the client demo, it says. So it actually started this in a new thread. We can see the server's running in a separate thread, and the keyboard is in fact free to do things. We could have run the client part of the demo in the same session, but it's probably more realistic, a bit clearer, easier to follow if we actually run the client demo in a separate APL process. So the client also starts with nothing, loads the HTTP command utility, which is a standard part of a version 16 distribution or later. Create a new instance of an HTTP command. Declare that we wish to make a post and to localhost port 8080, and we want to retrieve, or we want to interact, do the post to the getSign resource. We have to tell it that the content type is JSON to make it really valid HTTP, sorry. Use quad.json on our vector to set the parameter to a JSON string. So cmd params is this JSON string. Make the call to the server, and we get back an object from HTTP command run, which has a return code in it, which is 0, and the data. And that is JSON, so if we want it as an APL character vector, we would pass it through quad.json and get it back. If we were to pass it something that the function isn't going to be able to deal with, like putting the month as a name, the return code is 0 because from an HTTP perspective everything worked just fine. But the HTTP server has returned an error message, and in fact in the data there's a little bit more information. We can see how the function failed. Okay, so it's up and running, and we've tested it from APL, running the server in APL, of course, but also running the client in APL. The next thing I'm going to do is run the curl statement. So this is a Debian Linux virtual machine. It's actually one that I just have running. It's hosted on my Windows machine, but of course it could be a separate machine. And curl is a command line utility where I can type a statement like this one. So just to prove that this isn't all pre-cooked, we'll pick a different month, July, and we'll see that it computes Leo for us. So it's working and it's callable both from APL and from outside APL. So the JSON server, quick recap, it can serve up functions in a namespace. We just saw that. Actually, we're not quite done with the demo, I just remember. I need to go back to the server. Where do we decide between get and post is a question that's just come in, and that is where that was done when we set the CMD command property to post. That was how we decided we were going to do a post. There's actually a little bit more to the server demo. I'm going to show a different way of starting it. So we'll stop it, clear the workspace, load the server again. This time I'm going to, instead of creating an instance and setting all those properties before calling the start function, I'm going to use a shortcut called JSONServer.run and just pass it the two critical parameters, which are the port number, which it must have, and the code location. You notice in this case I'm not passing a reference to a namespace. There's a clear workspace here. There's no application code in it. I'm passing the name of a folder which needs to contain the source code for the functions. You may remember from the beginning of the client demo, or the server demo, that we actually loaded those two functions in from that folder into the namespace. So we could just have started the server and pointed it at that namespace. And the final thing to say about the server is that we can start it as from the command line. So if we launch Dyalog APL, load the workspace which is included in the GitHub repository, and set the port and the code location as environment variables or command line parameters, it'll start up and start serving your application immediately. Right. So you can serve up functions in a namespace, and that includes hash, the root namespace. If you use hash, the root, you probably want to set the allowed funs property to control which of the functions in the namespace you want to expose. So you don't have to expose everything in the namespace. As we've seen, you can serve up a folder full of dialog files, and in fact you can have nested folders or namespaces. So if you had namespaces inside namespaces or a folder with subdirectories, you would end up with URLs like this one here. After the 8080 /namespace/foo would go into a namespace and then call the function. It uses quad_JSON to convert incoming data and results to or from APL arrays, which gives us this limitation of not being able to do multidimensional data. But I think there are a few other restrictions, and it can be started from the command line. Right, and you can get it from GitHub. So that's JSON Server. Now that we have our JSON server up and running, the next thing we want to do to deploy it, to prepare to deploy it, is to create this Docker container, which we're going to do under Linux. So Docker containers are very much like virtual machines, but they are more lightweight. The big difference is they allow several applications to share the same host, but remain isolated from each other. So if you use virtual machines and you want to run several applications independently, you have to start several virtual machines each with a copy of the operating system. So they consume much less memory, and I think I mentioned that they're really very easy to define, build, deploy and run. If you read what magazines are saying, like ZDNet, they say Docker is hotter than hot, because it makes it possible to get more apps running on the same old servers, and it also makes it very easy to package and ship programs. There's a link here to the ZDNet article, and I've copied one picture from that article, which really shows graphically the benefits. So on the left hand side there we have a virtual machine configuration. So you have a server machine, you have a host operating system, and a hypervisor, VMware or Oracle VirtualBox or so on. And then for each application here, we're running a complete copy of the operating system on which it runs. So we can see the vast majority of the memory in this picture here are taken up by various layers of operating systems and libraries. On the right hand side here we have Docker, where we have a physical machine and a host operating system. But then the Docker engine allows the applications that need the same libraries. So the libraries and binaries here correspond to different flavors of Linux, for example. So we could be running Debian over here and applications on Ubuntu here. They all share the core of the operating system, but they can have different libraries and binaries. And much more of the machine is taken up by the applications. But the thing that's really exciting about these things from my perspective is the ease with which you can define and deploy them. because this little file that's visible on the screen right now, called Dockerfile, is a complete description of a Linux machine which will start Dyalog APL. The first line says we're going to start from another Docker base image, so that's just a base Ubuntu 16.04 system. We're going to add this deb file, which is the installer for Dyalog APL. So the add statements are saying take this file here where I'm building it and copy it to this location, the slash here, on the machine that's being built, the image that's being built. So put the deb file in the root, take the run file, which is the script that we're going to run when the image starts, put that in the root, run the installer for deb files. So this line of code is run during the build and installs Dyalog APL on the image. You can have a variety of statements that say which ports to open up, so you're setting up the firewall for this image. And then finally a statement that says what to run when the image actually starts up. And in this case, run is just a tiny little file that says start Dyalog APL enabled for RIDE connectivity. Yeah. And if you go into the GitHub repository, there's a folder called Docker, which contains about 5 files which we're going to look at in detail now, which set up a Docker image for running JSON Server. So if you've checked this out locally, it'll be in dev JSONServer Docker, or if you go to GitHub, it'll be at this location here. And there's a README file which describes what the files are. There's a Docker file like the one we just looked at, which defines the Docker image. Instead of run, we have a file called entry.sh, which is the script to run when the image starts. There's a script file to run which will build the image using the Docker file, a script file which will launch the image, and then a script file to clean everything up when you're tired with it. Now the Docker file here, you see, is rather larger than the one we just looked at a moment ago, but it's not as bad as it looks, because more than half of it is a bit of script which downloads the APL installer from mydialog.com. So if you're a support paying customer and you have permanent access to our repositories, then this piece of the script is going to download the installer from our website as part of building the script, before calling the dpkg-i to run the installer. If you don't need that, then we delete that from the file. Then say you had downloaded the installer a bit earlier, so you had the deb file. You just add that to the image, run the installer. There's a git clone which copies the contents of the JSON Server repository to the JSON Server folder on the machine. We're going to be serving up the sample application which is there. In production you wouldn't be doing that. You'd need a line of code to add whatever your application is to the image. Copy the startup script, expose 2 ports, and then when it runs, we run it. The startup script, again, it's a bit longer than the run we had before. We end up by running dialog -ride and launching the JSON Server workspace, having set these 2 environment variables. Again, this little piece up here updates the application on startup, so it either does a git clone or a git pull depending on whether the full application folder is there already. You might not want that, but we decided to leave it in case it was useful to you. The build script ends up calling docker build, setting a name for the image that's being created. And again, the rest of this is about prompting for the mydialog username and password and passing them to the build script so that they can be referenced by the Docker file for doing the download. Without that, the build would be this very simple little statement down here at the bottom. And then finally the run once you've built the container, you say docker run, and here we're saying it run it as interactively. RM, when the image finishes running, discard all changes to the file system that happened while it was running. So the effect will be that each time you start it, it starts from exactly the same point. The ports to be mapped, map this port in the Docker image to this port in the host, and the name of the image to be started. Right, so let's see if we can actually get that to run. Back to the virtual machine. I'm not going to run the git clone again. I was having a very exciting time running that just before we started because git was down. The next thing I need to do, so this git clone copies the contents of the JSON Server repository into a folder called JSON Server here on my VM. If I cd into the Docker folder, which contains those files we've just looked at, I can run the build. That will ask me for my user ID. And I suppose it found out that there wasn't anything to download using checksums or something, and just verified that everything is as it should be. The first time I ran this, it took about a minute, as I remember it. And then having done the build, we do a run. It starts up so that run started up the image, checked whether the JSON server code had been updated on GitHub, launched Dyalog APL, load the workspace, and loaded those functions into memory. If we now go back to the, I've already got APL sessions running. If we go to the client here and we redo this part here, we create a new command, we change the URL to be Debian 8. We need to set the headers. Let's use a different date. Let's do January 31st and run it and check the return code data. So it's Aquarius. So exactly the same as before, but now we're actually using this server which is running here in the virtual machine. And one of the things that really blew me away when Jason demonstrated this to me the first time was that, having started that, I can open another terminal window and I can say fire off the same command that was in the run statement, but you'll notice I changed the port numbers used in the host to be slightly different. So I'm remapping it to 8081. And you'll notice that in both cases the APL system thinks it's running on, it says it started the JSON server on port 8080, but the Docker system is doing the remapping. So if I want to call that one, I can go back here and change this number. Do it all again. Let's do May. And now we're getting the result of Gemini. So we're running, it took another split second to launch a second copy of that. So, it's really easy to do load balancing. You could launch copies of the same code on multiple machines and so on. Right, so that was very brief example of what you can do with Docker. So I claim, the main advantages of Docker is it makes it really easy to specify how to build a machine. It will build and rebuild that machine when you have changes to your code in seconds. It'll deploy images to other machines in seconds. We haven't seen that yet. That's the next step. And you can scale by launching multiple copies of the same machine also in seconds. So to learn more about that, docker.com, there's a community edition that you can download free. They have ways to eventually get money out of you, of course. And in fact, the next thing we need to do is something where you might quickly end up paying them a little bit of money, because they've realized that if you're going to distribute these things, you need a hub. So we're now going to upload this image to hub.docker.com, where cleverly they allow you to have one private image free, but if you want more than one, you have to pay for it, which is really a very nice way to do things. So you go to hub.docker.com, you fill in a Docker ID, an email address, you choose a password, you claim not to be a robot, you get an email, you click on the link to confirm your email, you end up here, you say create repository, you fill in the name of the repository and a short description and a long description and declare whether it's private or public. If you build something that contains Dyalog installers, we would prefer that you make it private, because otherwise you're distributing copies of the Dyalog installer to everybody, which would be a violation of agreements. And so let's see whether we can get that to work. Where were we? Here. Push. So the first thing we need to do. Right, the question has just come in from Gilgamesh. You built and run the Docker in a virtual machine. Can you not do it under Windows? I'm not sure exactly what the question is here. We might need clarification. I mean, I did do it under Windows in that I was running a Linux VM under Windows. Windows does support Docker for the construction of Windows machines. They're rather a lot larger than Linux machines. I'm twisting my head now to look at Jason, who's handling all the video feed. Can you actually build, Jason, a...
Yes, you can. Under Windows, if you run a Docker machine for the Linux images, then you end up running a virtual machine to create those images anyway. There's a command Docker machine that will do that on Windows.
Right, so I think the answer is you can do it under Windows, or you think you're doing it under Windows, but it's running a Linux VM to achieve it anyway.
Yep.
Right, so I just called this thing JSON Server. To push it up to to the hub, I need to give it a name like the one I have here, so Kromberg / JSON Server sample, because that's my application really, and it needs to be under my name. And then I need to say Docker login, and I need to log in. I have to remember my password for the Docker hub, and then I say Docker push push the image, and it figures out that I haven't actually changed anything since I was preparing for this, so that didn't take very long. Again, this thing, as I remember it, is about 200 or 300 megabytes in size. The first time I did this, it took a minute or something like that, and I think I was running over Wi-Fi. So you might need a wait if you're pushing something large, of course. So we've pushed it to the cloud. The next thing we need to do is to create a Linux virtual machine containing only Docker on this Elastic Compute Cloud, Amazon EC2. So EC2, Amazon's offering, is one of a large number of products on the market for hosting virtual machines. It's very easy to get started. They give you some credit, or I guess it's just a free tier where you can play around with small machines to get started. Microsoft, IBM, Google, I think there are dozens now of other vendors who all compete on differing parameters. You can actually get Amazon services through aplcloud.com, who are one of our partners in Atlanta. They offer VMs pre-built with Dyalog pre-installed and a way of paying the license fees to Dyalog on a monthly basis. We have an agreement with them for providing that. We're still working on how we properly license APL for use on virtual machines. And that's getting very urgent now with this technology where it's become so easy to do. But otherwise, you'd go to EC2, for example, you'd pick your operating system, a machine size, number of processors, how much RAM, what kind of file system, how many GPUs with how many cores. Obviously, you pay more for more power. You can get the virtual machines with pre-installed software, databases like MySQL, Apache, etc., etc., etc. Microsoft flavors, Linux flavors, Mac flavors, etc. You then install your own software, and then you start one or more instances. And what we're going to do here is really shortcut the whole process, really, in having already built a Docker image. We're just going to fire up the machine and then get our image from Docker Hub and run it. So the next few slides are some screenshots from the Amazon EC2 console. I don't have the screenshots of where I signed up for the service. That's many months ago. But basically you provide them with a credit card number and various other details, and they let you start playing. You can pick whether you want to use their services in Ireland. They've just started up in France. They're getting more and more data centers in various places. So I've picked the AMI, Amazon Machine Image. I think that stands for 2 with Docker. I've picked a free tier eligible general purpose T2.micro instance type with 1 virtual CPU, 1 gigabyte of memory, elastic block storage or something. I can't remember what EBS stands for. Low to moderate network performance. Click on that. There's some networking parameters that I didn't touch at all. I think those would be necessary if you wanted to set up a bunch of machines that were somehow speaking to each other. And there's various ways of changing how you pay for things and what kind of performance you get. And CloudWatch, detailed monitoring, protection against actual termination. I didn't look at any of that. I just moved on. You get to create and configure a security group. So I'm using, I had no, this screenshot I forgot to replace. Something went wrong for me when I was taking the screenshots here, and I managed to take a screenshot of PowerPoint while I was preparing the presentation. So I apologize for the small font here. But this is basically something where you configure the firewall. You say, here port 22, and I thought I was going to use 8123. You can say whether the machine should be accessible from anywhere, or you can limit the ports that the machine can connect on for each of the pairs. And then comes the slightly mysterious bit, which is nonetheless extremely important. The way you log into these machines is using secure shell, and you need a key pair. You need a file containing a private and public key. So you give it a key pair name and you click download key pair, and you end up with this file, and you can see the name down in the bottom there, a .pem file. And in the meantime your image is initializing up there. There's a screenshot here of a form I went to quite quickly after I'd started and stopped the machine. I got tired of it having different IP address each time I went to it. So I went in and created one elastic IP. So I got a fixed IP address and associated it with my machine. And then I realized that I actually needed port 8080 and 22 and 4502. And these are IPv4. They're here twice because there's IPv4 and IPv6 variants of each one. And now it's all up and running. And I want to connect to it with a terminal program so I can start doing stuff. And the most widely used terminal program is Putty. And there's a tool called PuttyGen which you need to run to convert the private key file in PEM format to PPK format, because otherwise Putty and also various other tools you get, at least under Windows, seem to prefer these private PPK files. So you just start Putty, you do file open and load the PEM file. You click save private key and save it as a PPK file, and you're done. Remembering where you put the file and so on, that's pretty important. Then you fire up this Putty terminal emulator. All of these, the things I've mentioned, these last two tools are free tools that you can download, free and open source. You can also pay for support. So So you fire up Putty, you create a new entry in the configuration. I've called it AWS JSON Server. You type in the host name that was given to you on one of those console forms we saw before. And then very importantly, you click on the SSH and you click on browse and you browse to that PPK file that you created. And then you open your terminal connection and you'll notice that you log in with EC2 user, which is the default user ID, but you don't provide a password because Putty is able to use the private key to get you through that. So now we have our Amazon EC2 machine up and running. We have a console where we can stop it and start it and see how much we've used and what it's costing us. So far it's cost me, I think, $1.50. I used it briefly for demos at the Dyalog user meeting in October, and my budget is still okay. So now we need to go to that machine, pull the image from Docker Hub, start it and call it from Python. So let's see, I need to fire up. I'm not going to do the Putty gen stuff, I'm just going to go directly to Putty and open my connection to the VM, log in as EC2 user. And then one of the nice things about Unix or Linux is that even when you've been out, the machine's been shut down, you come back in again, it remembers all the stuff you did recently. So I need to do a Docker login. I need to do a Docker pull. And unfortunately, none of this is taking any time. Again, this might have taken half a minute, or I think even less the first time I did it. I think these Amazon, and I don't know, for all I know, Docker Hub is actually running on Amazon too, so it's very, very close by. And then we've pulled the image, and now we just need to redo our Docker run interactive, throw away the changes when it's finished running, open up the ports 8080 and 4502, and it's running. JSON Server is up and running. So now, just to be different, we're going to use Python, the Python programming language, except PowerPoint is being stroppy. Why is that not running? No, couldn't start it from PowerPoint. So I've created a little Jupyter notebook there called. It's a technology which will very soon be available for doing demos with APL as well. And it's a file that has some, let's see, I had some trouble last time I tried restarting, just reusing this without restarting it. I'm going to clear all the outputs. Right, so I can go through this file which contains a bunch of text, markup text, and then some executable statements. So if I hit Shift Enter here, it executes that. And the last, or the only statement that produces any output is this print the payload. So I created an object with month 3, day 30, did the JSON dumps, which is the same as quad JSON, converting this object into a JSON array. And then I set the URL variable. And this, for some reason, never seems to work the first time you do it from Python. But if I just copy the IP address, go back to here and do it in APL, I don't know what I'm doing wrong from Python. No, it's not working from APL either. Oh. Is Brian listening? Let's try stopping it and starting it again. What could be failing here? Oh, I see the problem. Well, I see a potential problem. One problem is it's not on port 8081, is it? Ah, there we go. Right. So let's try running it again from Python. No. Well, last time it worked if we restarted the kernel.
I think you need to run the line under it. You put it into a variable.
Oh, yeah, but the star should... well, the law of demos. Could not receive data. Well, you'll have to take my word for it. This worked several times earlier today. Anyway, I mean, we saw it working with curl. This code should work from Python. We shall move on. Oh, PowerPoint is not responding. The last thing I wanted to show in terms of demos was that you can use RIDE to connect to this. Hopefully that will work. So we've got the address. So in RIDE, port 4502, the IP address of the machine, and indeed that does connect. So I'm not sure what's the problem with Python. Let's have one last stare at that for a second, and then move on. Yeah, it was working earlier. It will work, I'm sure, as soon as the presentation is over. Okay, anyway, so that's we're more or less at the end. Here's the full list of the technologies that were used. I don't think I'm going to read those up. Maybe when I've completely finished the presentation, I'll just return to this slide and leave it up. There's a number of things we haven't talked about today. Well, I did briefly mention the issue of licensing, and we've only really become aware of how fantastically easy to use this technology is now, and we're scrambling to think exactly how we want to. I think we need to come up with some new licensing models to allow people to very easily get started with this technology and then pay as they start taking advantage of it. Maybe Dyalog should be providing pre-built containers on a hub somewhere, containing my server, JSON server, other applications. This works exactly the same way on Mac OS, as far as I know. And then, of course, if you start serving up an application like the one we have here on the internet, you're going to want to look at security, how to deal with multiple different users connecting to it, how to deal with really big data volumes up on the cloud. And the final bullet point, they're just mentioning that The JSON server is also going to be something that you can easily start as a Windows service on a regular Windows machine without using the Docker technology. I've had a lot of help putting this together, and you can see I've reused an old slide here that I should have removed the headers from. But Jason is the man who's been using Docker internally at Dyalog for building things in the IT, and ran an internal training course recently that opened a lot of eyes here. Brian put together the JSON server implementation and the calculations. Of course, dozens of people in various companies are involved in putting all of this stuff together. Can't really thank everybody. The plans for the next webinar, currently we're planning that in about a month, Thursday the 15th of February, we'll have a webinar which will be about some user commands, mostly related to source code management tools that we're planning to put into version 17. We'd like to do a pre-release of those and get some feedback on them before we finalize the release. With respect to the last few issues I mentioned that we didn't talk about here, we're thinking of doing some webcasts. So those won't be interactive like this session today, but a series of small, maybe 5 or 10 minute presentations that you'll be able to view online, where we'll look at setting the JSON server up to run using certificates and validating client certificates, how to deal with multiple users, validating their credentials, and how to take advantage of Amazon and other tools with names like Rancher to automatically launch additional instances of your container as the usage grows. As always, please provide feedback to webinar@dyalog.com. That's all I had in terms of presentation. We'll now hang around for a bit and give people time to ask questions. The awkward silence will now begin. Or maybe I'll play around with. I promised to go back to this slide here to help generate questions. How long is the lag?
Well, you're still talking on my phone, so.
I'm still talking. Now it's going to go around in a loop. Yeah. Anyway, I suppose I am sort of easily excitable by technology, but this Docker stuff is just blown my mind, I have to say. The ease with which you can throw up little services to do things safely is astonishing. Even though the Python example doesn't work. Kernel. Restart. Run all. Hey, now it worked. There you go. So it can be made to work with sufficient restarts, and it's a computer.
Careful answering this one. I published something.
Right, so the question has come in asking whether you can launch the Docker container in a non-interactive mode and have Dyalog running without the session. And indeed you can. At the moment you have to use a runtime APL interpreter for that. The development system gets a little bit upset if you try and run it without any terminal attached. This is one of the things that we're looking at for version 17 as the importance of this technology is growing rapidly, is really taking a completely new look at the distinction between a development interpreter and a runtime interpreter. Obviously, our users need to be able to define applications in such a way that they cannot be debugged. You want to be able to certainly, I mean, it's not such a problem if you're running stuff in Docker containers, because then one of the big advantages is you don't ship code to customers anymore. So you don't have to worry about them being able to debug the application. You can close, not open the RIDE port and so on in the firewall. But if you are shipping code, you need to be able to say, well, this application, you may not attach a debugger to it. And that's perhaps the last distinction really between a runtime system and a development system that needs to be maintained. It would actually be better if I were answering these chat questions with text so that people got the answers immediately. But no more questions. Okay, well, I hope some of you found that interesting, and if you do get stuck into this and you have problems, please don't hesitate to contact us. We're starting to get some experience with this and should be able to help you get off the ground. Yep, thank you very much. See you in February.